Assalamualaikum and good day. Now we're going to start for the week 2 of our lecture. Okay. Now the chapter 2 is Coulomb's law and electric field intensity. Okay, we will cover the electrostatic part. Okay. So what does it mean by electrostatic? Okay. Electrostatic. Electro is the electric field, which is static means that if you have time, okay, and if you have the magnitude of E, okay, means your E field is vary with time. But in this case, we don't consider this, okay, we don't consider the element of time. So for your electric field, it's only consists of stationary charge, okay, stationary charge. That's why it is electrostatic. So for E field, okay, we can evaluate using Cartesian coordinates, or we can evaluate using cylindrical coordinates, okay, or we can evaluate using spherical coordinates. Okay, so R is the radius and Sadiku is using rho for the R in certain pages, so you hope you will not get confused. Okay, now the electric charge is the symbol is Q and is measured in coulombs, C. So electric charge can be found on a point, along a line, on a surface, in a volume, or a combination of the above distribution. Okay, so for example, what you can found the electrostatic charge is that from a wall. Okay, when you rub it to certain surface, then you have some static charge, right? So that is one of the common example. Okay, a point charge is that a charge so small compared to the distance. You see, this is the earth and this is the charge. Okay, so you can see the distance is so large compared to the point charge itself. Okay, a line charge is the charge distribution along a thin line. Okay, along a thin line. So this is your line charge. So you can see, you can have a charge here, you can have a charge here, sample, you can have a charge here by sampling. Okay, a point charge, for example, you can take a point here. Okay, now for a line charge, okay, line charge density is given by rho L. Okay, this is a line charge density with the units of coulomb per meter. Okay, for the total charge along the line is written as Q integration of L along the line, and you have dl. This one we will substitute accordingly. Either you will use Cartesian coordinates, or you will be using cylindrical coordinates, or you'll be using spherical coordinates. Okay, so this is your Q. So actually what happened is that when you have a line, for example, you have a line here, line charge. Okay, this is, let's say it is a very long line charge, and you have dl is actually when you try to sample the charge here. Okay, what is your charge here along this point? Okay, you try to sample, let's say this is a small length. Then when we want to take the whole total of the charge, okay, that's why we use integration. Okay, so dl is considered a small section by sampling. Then when we want to do integration, we take the total charge. Okay, a surface charge is a charge distribute on a thin sheet, okay, on a thin sheet, layers of surface charges inside a capacitors, okay. As you know, capacitors is actually, we have conductor separated by a dielectric, okay. Now, a surface charge density is given by rho s, okay, rho s, and then the unit is coulomb per meter square. This is corresponding to surface. Now, the total charge on the surface is written as integration of s, rho s, and ds. This one will be using the surface accordingly to your Cartesian coordinate, cylindrical coordinate, or spherical coordinate. For example, if you have this surface and you have a sample of here small charge, this is your ds. But if you want to know the whole charge, then you use q over s rho s ds to consider the whole charge, okay, of the thin surface. Volume charge is a charge distributed inside a volume. For example, a star, okay. For example here, okay, inside a volume. Now, a volume of charge density is given by rho v, the same when you have rho v, volume charge density, so coulomb per meter cube, okay. So cube here is main volume. So the total charge in the volume is written as Q equals to integration of V rho V dV, okay. For example, for example, if you have your X, if you have your Y, and you have your Z, then you have a volume. Let's say you want to know the total charge in a volume, okay, in the small volume, okay. So this is the sampling of the charge over the volume, and it is dV small, okay. So you see in this question how we solve it. What is our chosen coordinates for dV? So certainly is a Cartesian coordinate, right? Because it's easier to use Cartesian coordinate in this kind of condition. But let's say if you get cylindrical and you need to know the same, and then it's imagining a sampling charge here, so your dV should be wise using a cylindrical coordinates. Okay, thank you.